So today's webinar is going to be about Build or Buy, understanding when to use AI services and when to start from scratch by Claire Houston. First of all, my name is Sapphire Duffy and I'm a Leadership Fellow at WWCode, and I joined the WWCode team a few months ago now, and I am a Leadership Fellow with Naomi Freeman. So if you're interested in anything to do with the data science track, or interested in volunteering, or just want to know a wee bit more, please feel free to email myself or Naomi. And this is our awesome data science team. So this team are really amazing to work with, and they'll work really hard in leading our community. So a massive appreciation to the data science track team. And for all of you that aren't familiar with WWCode is a global non-profit organisation dedicated to inspiring women to excel and encourage them into technology careers. And our vision, so we envision a world where women are proportionally represented as technical leaders, executives, founders, VCs, board members, and software engineers at all levels. So every day at WWCode, we try to understand the gaps and what we can do to help more women excel in their careers. So across the world, we have 230,000 members, and this was just announced about a month and a half ago at Connect Digital, and we are super pleased to have this many members now, and it keeps growing every day. And we have 70 networks in 20 countries, and we have members in over 97 countries. And so far we have run 10,000 events, over 10,000 events, and we give away $1,025 worth of daily conference tickets and $2 million worth of scholarships. And on their WWCode website, you can get access to jobs and resources, and there's infinite connections there. So our movement, so as the world changes, we can be a connecting force that creates a sense of belonging while the world is currently being asked to isolate. And our code of conduct, so please take a look at our code of conduct if you haven't done so already. We follow a strict code of conduct that is embedded into our community, and we encourage our members to have an inclusive mindset. So if you feel something like isn't right, you can fill out the incident form and we will look into it. You can always email Naomi or I as well. So we want this community to be a place where everyone feels safe. So a little bit about our track communities. Our track communities were founded about a year and a half ago, and we got a lot of requests from women who wanted to deep dive into technologies. So last year the 6 tracks were created. And of course this is a data science track. So if you aren't a member yet, so you can join through our WWCode website. So it's www.code.com/data science. Is our data science page, and you can register as a member. And you can also join our Slack community group where we all stay connected. So in data science, we run tech talks, workshops, tutorials, training, live streams, study groups, and yeah, so we run a lot of things, including this webinar today. So I want to give a huge thank you to our amazing sponsors, the Home Depot and Bank of America. We appreciate your sponsorship so much, and this helps our community be able to run events like this here, so thank you. And if you want to get involved and help the WWCode data science track grow, you could go to the WWCode website and register for interest as a volunteer, or you could reach out to Naomi and I. We are looking for leads, evangelists, and volunteers. So if you have like maybe a technical background and you have strong leadership skills and you want to be able to lead events, you can do that. Or maybe if you want to be an evangelist and spread the word about this community, and also, oh, sorry about that. And also, yeah, like apologies. There we go, that should be it, coming back now. Yeah, so evangelists being able to help out with our social media pages and our graphic events. So if you're interested, please reach out. And I'm going to introduce you to our speaker today, Claire Houston. Claire is a senior AI engineer at Kainos, and Claire is working primarily in AI and data science, machine learning, and Claire is a core member of the artificial intelligence practice at Kainos in Northern Ireland. She has experience in neural networks and deep learning, and has recently been exploring the use of chatbots and NLP to change how customers interact with services. She is passionate about lowering the bar to use and understand AI, regularly speaking at events about machine learning, bias and data and more. And Claire, I'm super excited to listen to your talk today, because I've heard you went to conferences to listen to you in the past, and your talks have been incredible and I've learned so much. So I really can't wait to pass it over to you. Thank you.
Thanks, Sapphire. That's some introduction. Hopefully I can live up to the hype. Hi, everyone. It's great to be here, and thanks so much for all of you guys joining in from absolutely across the world. I was saying whenever people were joining initially that this is the first time that I've done this kind of webinar thing, even though I've spoken at conferences and that kind of thing before. And it is just brilliant to see everybody kind of coming together from all over the place to be able to link into this, because as Sapphire says, something that I'm passionate about is that I feel like everybody should get the chance to get involved with AI. There's this kind of perception that you have to spend ages learning how to do it, and you need a degree in it, or you need all this education in it, but it's really not the case. There's so many ways to get involved, and there's so many different there's so many kind of different levels you can be at, and you can still use and get the benefit from AI. So without further ado, I'll kick off and start sharing my screen. So Sapphire, can you see that?
Yep, I can see your screen.
Perfect. Okay. Well, everyone, I would like to introduce you to Sally. Sally is a coffee shop owner and has her own website, and she has been doing some thinking and would like to expand her business. She wants to come up with this great new thing that she'll be able to attract more customers and better serve her customers that she has currently. So she's thinking and thinking and thinking, and she comes up with a brilliant idea, $1 million idea. She knows it'll work. So she wants to get it out there. She wants to figure out how she can best access the customers that she has currently. And she has a website, which is pretty good, but she wants to go that step further. So she introduces a chatbot, which I know we've all used before, but she wants to introduce one that will be able to access her brilliant $1 million idea really quickly. So we've got a completely different stranger exemplifying how this product would be used. It'll be a case of, can I use the project? No problem, the connection will be provided. But how will the service actually be connected? Well, there's a few different steps that are going to be required, as we'll discuss later, but the main way that it'll happen is through machine learning. We know that if we want to actually, and when I say speak to the bot, I mean literally use words, not typed or anything, like speak as I'm speaking to you guys, and actually have that conversation, have that real personal conversation with the chatbot to actually be able to use that service. Because it's 2020, the world may be on fire, but the tech is pretty good right now. So how are we going to introduce this machine learning? How are we going to make this the best service it can be? Well, there's a lot of ways to do it. Now, you might be tempted to roll up your sleeves and think that you have to start building your own models to do it, but that isn't necessarily the case. Or you might be thinking that this is far beyond Sally, who works in a coffee shop, that she might not be able to do it. But that isn't the case. There are many different options to get started. And we're going to consider the two main ones of, do you build your own machine learning models, or do you buy? And how do you effectively leverage both of these? So today we're going to cover, what is the difference between buying and building for machine learning? How do you actually know when to buy and when to build? What are Azure cognitive services, or more generally, what are AI services? What do I mean when I say that? And how can we best leverage those services? So Sapphire has already provided a brilliant introduction for me, but something that I want to touch on as well is that as a big part of my role is productionization. So that is whenever we maybe receive a machine learning model, or we get a request from a customer that they want to get something into production, or they want to immediately connect with their customers. So there's kind of a running joke that I'm not sure if many of you guys would have heard of, that machine learning models are often deployed to slideshows. So that is a case where the model is created and it's thought through and it's great accuracies, but it's in somebody's laptop. It can't actually get off the laptop and into production. And that is something that I think, and it's that kind of step, getting it off people's laptop and live, that can be quite tricky for a lot of people. And it's something that this kind of talk will focus on. To say as well, this talk won't go into too much detail around, say, definitions of machine learning or how to build a neural network or anything like that. We're going to have a look at how to actually get into production, how to actually leverage these services directly for your customers. So, build versus buy. Which is which? So when I say build, I mean you've got your raw data, you feed that into a machine learning algorithm, and you get a machine learning model. You train a model based on the data you have. And that is an important first step, and actually can take a lot of time to prepare that data, to get it in the right format, to pre-process it, to do all the things that you have to do to get it ready to be fed into a model, and actually then you have to get good accuracy out of that model. So when we say testing, we mean making sure that the accuracy is good, that the precision, the recall is good, all these metrics that kind of tell you what is the quality of your model actually like. All very important. But then whenever you're talking about production, you actually have to think how you're going to deploy the model. So this is a diagram that I got from Microsoft Azure. And you can see here, there's a couple of core steps after you train and test. Like those are the first 3 steps, which are very important, but you also have to register and manage the model. You have to build it and deploy it. And then there's a reason this is a cycle, is that you continuously have to maintain your model. So you have to check, is it still working 6 months down the line? Is it still working 12 months down the line? Is it still working 2 years down the line? With machine learning, it's very tempting to assume that once you have the data, it's good to go. Once you have the model, it's good to go, but you actually have to continue to think about it further down the line. So the example I'm showing here on the screen is Microsoft, but there are lots of different kind of online services you could use to deploy a model, such as AWS or SageMaker, or their offerings from Google as well. So if we're thinking about build your own, there are some key considerations that you should think about. What are the skills required? That you need to have skill sets of a data scientist, an ops, and a software engineer, ops engineer, and a software engineer. And you need to have all of these skills because you're doing all the data science that I described initially of building the model, training, testing, and so on. You need ops to be able to actually deploy the model. Models don't deploy in the same way a lot of software is expected to deploy, and it needs to be put in things called Docker images. And there are just the additional steps. It's not to say they can't be done, you can't learn how to do it without no problem. It does just require a separate skill set. And then you have software engineering because, well, you want it to interact with your website, or in this case, we want it to interact with Sally's chatbot. The cost for build your own can be quite high because you've got to, if you're training quite a big model, and as some of these that I'll describe later would be recommended to be, it can be quite costly to train it. You sort of hear horror stories occasionally of people racking up enormous bills on Azure or on AWS with the cost of these models training, with the size of the VMs that are required. So that can be one set of costs, but also whenever you're running it, if you leave the model running all the time, then that you have to pay for that service. If you then want it to only pay when it gets hit, so whenever you make a request to get an answer from your machine learning model, you would pay it per request, but then that might result in a bit of latency for the user. They might have to wait around a while. So the cost for deploying your own can be quite high. You have to think about data gathering. So as I've mentioned so many times, data is critical when it comes to machine learning models. It has to be of the right quality. You have to make sure you have it. You have to get it from historical data, modern data, keep siphoning it in, and that can take quite a lot of time. The flexibility, however, and this is the big benefit of build your own, is that it can do exactly what you intended to do. If you've got a super niche example, you're able to create a model that fulfills that need and meets that need, and that's where build your own really stands alone. It's brilliant for that. And then finally, model maintenance is also required. So this is your model, so you're responsible for ensuring, as I said previously, 6, 12 months, 1 year, 2 years down the line, it's still going to be as good as possible. Because if the model quality starts to dip, you'll soon be hearing about it from your customers. So it's important to keep that in mind. So whenever I say AI services or machine learning services, these are, pardon me, some of the ones that I mean. You've got language, speech, machine learning, vision, search, and knowledge. Now, some of these might not mean a lot, but you can see here, computer vision would be kind of object recognition, language, text analytics, what language is someone speaking. You've got speech to text, text to speech, and that kind of thing. And you can read some of the rest on the screen. An AI service is literally just an API call that you make a request to. So you would pay per request, you would pay a small fee or maybe slightly bigger fee to get that information back from Azure in this example. AWS offers something very similar. Same with Google. In fact, I would actually recommend, if you're intending to use these, that you go and compare the actual services because different ones have different costs, different offerings, and honestly different quality levels. You'll often want to chain them together, as we'll kind of see later, but it's important to kind of keep that in mind of you don't have to just stay with one. So whenever you're actually calling a cognitive service, you'll need to set an account with Azure or so on. And you have to sign up with a credit card, but there is free tiers and there is a free month's trial, I think. With a lot of this stuff, you get free credit and then you get some limited stuff for a year. But the examples that I'm going to be showing continues to be free, as there are free tiers associated with this that you can always kind of remain within. So essentially, whenever you are testing or just trying out different services, you don't actually have to pay anything for it because it allows you to actually get used to the service and then actually go on to use it. And that's kind of why it makes sense for Azure not to actually charge you for those. So what are the skills whenever you're buying a machine learning service? Well, you need some software engineering skills. And when I say some, I really do mean some. It's not a wow lot. You just need to be able to make the call. But on the bright side, you don't need extensive data science skills or ops skills because you are just making that API request. So the cost can change from a little to a bit to a lot depending on what the type of request is. So say if you're doing something very image heavy or video processing, that could become quite expensive. So say if you were just offering a free service and hitting those requests, that could become very expensive for you. But if you're doing some simple text analysis or something that's very common, very quick, it can be very cheap. So it's worth checking out how much those actually cost. So data gathering isn't required. So this is a default machine learning service. So you're able to just piggyback off what's already out there and just call in straight away. You don't need to do too much setup. However, this is the downside, is that there's low flexibility. So it needs to already exist. The problem needs to have been solved by somebody else and they need to know it's there. Basically, you can't come up with a bespoke model. It's just going to sit there out there for you to make that request. However, again, on the bright side, model maintenance isn't required because it's a service that they look after it for you. Essentially, when it comes to an AI service, think that there are these models out there that Azure is looking after maintaining, building, data gathering, all that for you, and you're just making calls to it occasionally. That's probably the simplest way to explain that. So those are my kind of most heavy knowledge-based slides for you. So I'm going to kind of cover in greater detail as we go through some of those. And then if you guys have any questions on those, I'll be happy to take them at the end. So whenever we're trying to decide between, do we want to build a service or do we want to buy a service, there's three questions that I always ask myself, and I ask myself every day on my job. I ask, is this a solved problem? Can I access the data and will I get good results? And if there's problems with any of these, then you shouldn't build your own model and you should look to buy, or vice versa. So is this a solved problem? Has somebody out there already got a machine learning service that can already do this? Can they already solve it? If that's the case, you're more than likely going to want to go for it, because often with machine learning, if you've been doing it for longer, it's frequently better. And if they have a lot more data and time working on it, it's usually better. That link kind of ties in to the second thing of, can I access the data? So do you have access to data, first of all, that you want to train, that you would be training your model on, that you would be using to feed in Do you have examples of all the data? So often we can see data that's really skewed, that it is, you've got lots and lots of one class. Say if we are talking about cats and dogs and you want to classify between the two, you could have 70,000 records of cats, but only 1,000 records of dogs. So you can see there's quite a big skew. So it might not be able to recognize it as well. Or say 1,000 records of dogs. So you can see that that's a problem. There's also the question of, you may think you have the data, but do you have the right to the data, such as we've seen with GDPR? Can you actually process the data and use the data in that way? So all kind of important things to consider. And when it comes to AI, you can't get away without having the correct data. The data is this machine learning model. The model is the data. So that is something critical to keep in mind. And then finally, will I get good results? This might sound a wee bit like I'm putting the cart before the horse, if you'll use the phrase, but essentially it's worthwhile to build a small prototype before you pump loads and loads of money into thinking this is going to work great. You can run off a small subset of the data and actually check it out beforehand and see if it's likely that you will get good results, because you might find that you just don't have the resources, or you can't find the right model to work with it, or you know that you're going to need a massive model to train it, or so on. It basically will highlight a lot of the problems. So the time's come, let's start hooking up our system. So the first step that we'll need for our system to connect Sally's customers to her brilliant, brilliant product is speech. If they're talking to a chatbot, then we need to be able to take the input speech and actually decode it into input text. And this is done by taking in the sound, which is hello in this case, or a phrase, taking in a sample voice clip, convert it into the wavelength, then breaking this wavelength into individual numbers, individual frequencies at a certain point. These then get processed in a neural network, quite a big neural network as well. And then that'll be then matched to a word in a database. So you can already kind of see, I've given quite an easy example of hello, but there are, as we've kind of discussed, the world is quite a big place. So a lot of people will say individual words in very, very different ways. There may be different phrases, like I could say, hey, how are you? Lots of different intonations, so lots of different speakers. I'm sure most of us here remember whenever voice activation on our phones and that kind of thing just didn't work as well if you're female as you are male. So there's lots of different, and then that's not even getting into if words roll together, if you speak very, very quickly, how to actually break those individual words up for the thing. So as you can see, it's a bit of a complex problem. So we go into question time. So first of all, is this a solved problem? Well, as I just referenced, yes, we've got the likes of Alexa and Google Home are out there already, speaking to us on a regular basis and having absolutely no problem with it. Can I access the data? Probably not, unless you have Google and AWS's version of that many speech recordings, and not only that, but translations of those recordings. Something to keep in mind is that you not only have, when I say data, I don't just mean do you literally have the data, you have to actually have the data and the correct versions of the data. So if you're actually training a model, you need to have, this is the data, and then this is what it means. So the class that it's associated with, or that kind of thing. So we would have to have loads of speech records and translations. Just another thing to keep in mind. And then finally, will I get good results? Probably not, as if you're just trying to do it in a simple model, it could very likely require a large-scale neural network that would either require a large, quite a high skill set, or not skill set, sorry, quite a high processing power and GPU to actually train it and keep it regularly up to date if we're matching all of the speech records. So this is a bit of a no-brainer. It is definitely worth to simply buy it. So here is the example I have. So you can see here, this is whenever I go through this week.
Hi everyone, I hope you're enjoying the presentation so far and continue watching.
So you can see there that it actually was able to, this is a previous example, it was actually able to listen to what I said and actually translate it pretty much exactly. Something that I will say here that was quite funny is I tried like 5 different times to get it to recognize women who code, and it got like women who and then didn't get code, or it got women and then code and then not who. So I went for everyone instead. You can see that it's a pretty good translation for what I said exactly. But you can see here that is also a very simple amount of code. And I've pulled out the kind of the key things the key points here. So you simply import the package, you declare the objects, so you set up the config for it. So this is a subscription key and the region. So whenever you're doing each of these, you have to go on to your Azure portal, your Azure account, and actually set up a speech resource. And that'll allow you to link in. So that is the kind of cost, that's the object that you're hitting. And then you set up the speech recognizer, and then you're able to call it, so you recognize the text. This is a super simple example, just listening to what I said exactly, but it can be quite easily implemented into a much broader service. So we've got natural language processing is the next step. So now we have the input text, we then need to be able to extract the information from it into entities and intents. So essentially, natural language processing is allowing computers to understand what human language is. So what do we actually mean when we say the words we say? So what is our meaning behind it? What are the key words that we're saying? What is our intent? What do we want to happen? And we can all do this very easily while we're listening, but it's actually very complex for a computer to do it, as it's used to working in simple numbers. So how do we convey that understanding and share that understanding? Well, some of the ways we can do it is, if we look at the original phrase, we can say, "Hi WWCode, I hope you're enjoying the presentation." So whenever I say that, you can very clearly hear I'm fairly positive, I'm speaking English, and I'm talking to a group of women about code in a presentation. That is probably things that we nearly subconsciously pick up. But for a computer to do that, it's needing to go through some machine learning processes to actually extract that information. So if we then look to the actual questions again, is this a solved problem? Yes, there's a lot of services out there that allow you to do this, but there's also some free ones that I like to highlight, such as Spacie and NLTK, which operate under named entity recognition and offer more services some are machine learning. NLTK is really great if you want to pre-process. So if you're ever looking at natural language processing, I would say definitely go for these options rather than building your own when you're looking to pre-process. Can I access the data? Probably not, unless you have access to countless rows of questions and requests, and then what was the next action. So you not only have to keep in mind what the phrase was that was written, but what was either extracted from it or what action took place. And finally, will I get good results? So you need to make sure that the model is good enough that it is able to actually figure out what people are doing, because natural language, while great and feels very natural when you're saying it, it is one of the few things that AI hasn't quite figured out yet, in that it can get quite frustrating if you're trying to talk to something and it doesn't seem to understand what you're saying. It gets the gist, but it's not quite right, or it just brings you down the wrong path, and you're likely to just rage quit and just exit out of whatever you're trying to interact. So there are quite high levels of expectations on these, and there are quite high risks if it is to get it wrong. Well, high risks as high as ever could be in shopping or that kind of thing. So in conclusion, a lot of these kind of add up to buying is very probably the best option. So here now we've got the example of Azure Text Analytics. So you can see here there's a lot more code in this than the previous example I showed, but that is because it is actually running through a number of different services. So the thing to recognize here is that I'm calling on 5 different services, and this would require 5 different machine learning models, each of which you would have to train, deploy, test, maintain, and all sorts. So we can see here, with the inputted phrase of "Hi WWCode, I hope you're enjoying the presentation so far and continue watching." Really hoping you guys are enjoying it so far. But you can see there again, the sentiment is positive. Like I was saying earlier, that you've got the text that's pulled out, code and presentation with kind of the main entities, and women, code, presentation. So all of that information is extracted, and the computer is able to action those. It is able to know that it is best to do something about those and kind of take that process in some way, go to that next step, versus it just being around a load of buttons that have to be pressed. Instead, it's quite a natural process of just talking and saying something as you would in your natural language. So here are the key codes. So we've got install the package, authenticate the Azure, And then you've got at the bottom, there's the 5 things that took place. So sentiment, check language. So this is something that can be quite important whenever you have an overall website, is that if you've got a chatbot or it's like sitting there, it has to make sure that it can understand the language that's being spoken. So if you've got a chatbot that can only respond in English or only respond in French, that you want to make it clear that you want to check to make sure that the person is actually speaking that language. Or you might want to use one of the translation machine learning services that are out there and do a translation of the text to allow it to operate within kind of your ordinary bounds. Say if you want to translate from English to French, then a French chatbot can actually still provide answers. It's funny to think of chatbots having a designated language, but it's true. And then you can recognize linked entities and extract key phrases. So all very helpful things. And again, as I said previously, each of these require a different machine learning model behind it. Speech synthesis is then our final step. So we have our entities and intent. We pass it into the brilliant, wondrous service, the product that Sally created, and we've got some response text out that we would like to feed back to the user. But of course, we want to speak this to the user and we want to actually say what we're thinking. So to do that, we have to synthesize the text into speech. This is done via text to voice. So we can see here that we take the input sentence in and we break it up into individual words. So this is very important then to remember the context of what's being said. So here's a great example of 1843, which is I automatically read that as 1843 and that's what we say on our heads. But if a computer's just reading that, there's a very good likelihood that it would just say year 1843. Doesn't quite trip off the tongue and would be quite jarring if you're listening to it. So there's that kind of processing step that needs to happen initially. Then needs to get converted into phonemes, which is essentially for every word, there's a set way on how to actually pronounce it. So that is, there are 26 letters in the English language, and I think there are 40 phonemes for how you actually pronounce those. Do you ever look for a word on Google and you see the dictionary definition, and then under the dictionary definition, there's a load of random letters on the screen? Those are actually phonemes, and there's actually a correct way to pronounce each of these words, and that people who can read these can actually translate that into a word, as this computer would do. So it would then convert that to sound and then play the voice that gets generated from that. So there's a couple of steps here that involve machine learning. So decoding the sentence into what should actually be said, and then actually converting into a voice that sounds vaguely humanoid. So I'll show you an example of that later on. But first we have question time. So is this a solved problem? As we saw previously, yes it is. We've got the Alexa and Google Homes that are sounding more and more lifelike, and there are different options for them now. Instead of just being female, you've got male voices coming through on this, which is brilliant. Can I access the data? Unless this is an interesting one, you would not only need examples of how text should be spoken, like how with the example of the 1843, but also how you want it to speak. And this is something that people have been working on for a very, very, very long time. Text to voice has actually been around, I think, since the 1950s. There's examples of it earlier than that. All of us know it from the late great Stephen Hawking. His voice was obviously completely synthetic. This is less of in parts of machine learning service, but you can see here there's important bits of machine learning that could be integrated to improve the overall service. So you can see here that probably can't access the data. And finally, will I get good results? Again, there's some quite big models that we required to actually make sure that you're processing it right and saying the right words, but also that you're mimicking human intonation effectively. Otherwise, you can wind up with that kind of uncanny valley, very robotic sounding voice. So in conclusion, would still recommend to buy it. So we've got an example of it here.
Hi, WWCode. I hope you're all still paying attention.
So we can see here, again, it was a very short example of what code was actually needed, similar to the first example. And the great thing about Azure is these are both speech examples. So you actually just set up the one resource for that. You do the same config, but instead of a speech recognizer, it's a speech synthesizer. and you pass it the same config, and then you run the code to actually translate and synthesize the text that you give it. So that hits a different model and will cost maybe a different amount, but it's still, you're able to use the same resource just for kind of speed. So I'll just take 1 second. So as you can see here, every example previously I've given, I have recommended buying, and that is, I swear, so much more common than you would expect. Because often the big guys have got this brilliant service out there, Azure, AWS, Google, all have these really great services. So it makes sense to actually use those and leverage those. And there's still an awful lot of work not an awful lot of work, but there still can be a lot of work to go into kind of making it unique. Like it's a standard service, but it's all about how you present it and what you do to it. So when I say work, I don't mean it like, oh, it'll take a lot of work to get it working. I mean that it's something unique that you're creating and you're selling, and you can still make it very unique to your service and your product to actually still benefit from that and make money in that. It's kind of a broad tool that you can leverage, but it's not going to be everything to everyone. And there's also examples of where it just won't work. So you may remember that I keep raving about Sally's brilliant product that she came up with at the start of the presentation. Well, you may have been asking yourself what that was. And it's the secret sauce of the whole thing. None of this would be able to set up without it. And it is a recommendation engine. So it is a service that is able to actually recommend what coffee is the best for each customer that comes through her website. She's been thinking about it for ages. She's got the customers in her history. She's already recommended them loads and loads of good coffee. She's got loads of examples of it, and she knows she can recommend them such good coffee that Starbucks will just be blown out of the water. So this is the secret machine learning model that sits at the heart of this entire system. And it answers the questions great. So is this a solved problem? No. No one out there has tried to do what Sally is trying to do. They just think that people know what they want when it comes to coffee, but they don't realize the granularity or the bespokeness of this and don't have the examples that she has. Speaking of examples, she has lots and lots and lots of this data. She has lots of user interactions where she recommended them great coffee before, and she continues to do it. She wants to speed up that process. And thankfully, the way that she has collected that data, she is allowed to process it. And finally, has she got good results? Well, the initial prototype does look very promising. She's hired somebody to be able to train this model for her, and she's getting great results. So it's looking good so far. Now, the only step is build. It makes perfect sense. It answers all 3 of the questions positively. So she's going to build it and get it working for her website. So what is the next step? Well, in that case, you could use Azure Machine Learning Studio. It's just one example of a way that you can create, train, deploy, or maintain your model. So it allows you to get up and running. You can either do it with code or drag and drop, so you can actually pull it in. So so Sally could probably give it a go doing it herself with some technical know-how. Again, not even so much coding know-how, is just an understanding of how things work, and also provides assistance with the data. Although it's still got some kinks that it needs to work out, but it's still a really great service. So you guys might remember the initial diagram that I showed at the start. This is actually a model of how ML Studio actually works in the background. So you can see here that train, register, build, deploy. And all of this allows you to keep a really good eye on maintaining your model, something that it would be critical to Sally and her coffee shop website to make sure that she is actually still recommending the best coffee to customers, and will then be able to recommend new coffee whenever it comes in. So all very important. So we did it. We've got our system. Sally's got a fully fledged working system that leverages machine learning exactly in the right way at the right time to maximum both efficiency in terms of quality and in terms of accuracy to make sure that the customers are getting the best deal. And Sally is maximizing her money whenever she is paying for these services. So in conclusion, not one shoe fits all. I can't just say you want to buy all your machine learning services or you should build all your machine learning services. I took you through an example that seems pretty obvious whenever you look at it. Of course, we should use online speech services, and of course we should build our own bespoke model. But it might not just be as simple as that whenever you're actually doing this. So it's important to ask yourself those 3 questions. Do you have access to the data? Is it a solved problem already? And how good is your model, your initial prototype? Will you get good results? But the most important thing that I want you guys to remember is that you don't need to be a data scientist to get started. You can just give it a go, you can call those services, and it'll give you a feel for how these actually work. And it'll allow you just to get started if you have your own brilliant idea like Sally. So today we covered the difference between buying and building for machine learning. You now know when to buy and when to build. You've got a good idea about some of the Azure cognitive services that are out there. And again, you can use different ones, not just Azure, AWS and Google have similar offerings, but you also know how to best leverage these services. So thank you all very much for listening. It's been absolutely a pleasure talking to you. That is my Twitter and my LinkedIn if any of you guys wants to follow or connect with me on there. I'm hoping to release a blog sometime in the near future about some of how to use some of these services if you want to follow to hear about that in the future. Thanks, and I look forward to answering some of your questions.
Thank you, Claire. That was really awesome. I learned so much from that. Thank you so much. And you got a lot of excited attendees here asking questions too. We actually have Claudia. She said, "Hi Claire, I was actually looking for experts on speech recognition for a project we are working on in my firm. Would you mind picking up your brain or advising us?" They're based in Peru.
Oh wow. Yeah, sure. I'll reach out to you, Claudia. Tell you what, do you want to add me on LinkedIn and we can have a chat there? Is probably the best place to kick things off. And then I can even point you in the right direction, or we can have a chat there. If you want to give me maybe a wee bit more info in the connection.
Claudia said, "Thanks, I've already added you. Great presentation." Okay, so we can link up. Okay, and we have a few people ask questions in our Q&A. The first one is, can you customize the APIs for your specific needs?
So frequently, and that's actually something that my company would do a good bit. It's something that we're quite used to. So you can customize it in the sense that, so basically, if you've got, say, a text extraction, so you're extracting key text and you're using those entities, well, you can figure out what entities you need to extract and process those in a specific way, so you can make sure that you're doing it. Some of these services also allow you to train around specific data sets. So say if you've got a few examples of what you need, so say a great example is Azure offer vision, so you're a vision model that you're able to add and recognize specific examples. So say if you were, I know I'm on the coffee shop example, but if you had loads of different types of beans and you wanted to recognize those, you would be able to train on, say, 30 images with different examples and different classes, and you would actually start to be able to get results. So it leverages an existing model to actually improve, to give you a pretty good accuracy to start with, and then you're able to use that service that's very, very bespoke. There's another version of that allows you to do the same with text, although the one I'm used to is Comprehend, which is AWS, but Azure might offer the same thing. So that kind of answers the next question as well of you can have a foundational model and then use your own data. Although I will also say with that, there are pretty big models that you can start to train with initially that are free that you can then use to it's called transfer learning. And it's used a lot with deep learning that you can then use to train in your own specific examples if you want to go down the more machine learning route and you want to deploy and create your own model. So there's 2 examples of whenever you can leverage an API for that, and you can build on foundations for both buy and build, which I know doesn't answer, maybe adds to the options there, but there are definite ways of doing it both ways depending on what your skill set is and what options you want to go down.
Okay, cool. Thank you. And yes, so we answered the next question there. And then the third one here is, the examples given are NLP, but I'm wondering about buying supervised learning applications for classification. Also wondering about using own data within such applications for recommender systems.
So that would be, so for the first part of that, that's what I touched on of, I'm assuming maybe you mean vision. If you mean like vision classifications, recognizing if something is one thing, or you could also do text classification. Both of those, there are services that allow you to classify those, both AI services that you can train to work more specifically for your services. I'm not sure what the Azure version would be, but I know Comprehend is, so that's NLP, the Comprehend would do that. Or there's the Azure Vision one that I referenced previously that you're able to train on a small subset of images and perform classification. For using own data within such applications for recommender systems, that would be a case. I'm actually not entirely sure what you mean. If you could write another question expanding on that a little bit, it'd be helpful. If you just explain that, you say recommender systems and an explanation, and I'm happy to touch on that. I just don't want to go down the wrong route.
Okay, awesome. And then the next question is it possible for us to download the slides? Claire, are you okay? Are you happy to share your slides?
Yes, no problem. I'll yank a few of my random notes out of them, and then I'll share them with Sapphire, who can send them out to everybody.
So I'll actually post them into our data science Slack. So to join our Slack, if you're not a member already, I just put a wee invite link there in the chat. Okay, so the next question is, sometimes business areas have a particular definition of rules that maybe a solved problem doesn't include. What are the recommendations in that case?
Yeah, that's something that you can see pretty frequently of you've got a solved problem that's almost there, but it doesn't quite hit it. So that would be maybe it extracts the entities, but it doesn't actually tell you what to do with it, or it doesn't actually allow you, maybe it doesn't have that next step. So that would be the thing I would consider is, first of all, is there options to train the service? So as mentioned previously with Comprehend, you can train some of them, but also can you then take in what you've got? Because these things are great for giving you nearly too much information, like they'll throw information at you. And you're able to do it. A great example of what I did was with a service called Textract, which was a text extraction tool. It was an OCR tool, and it extracted all the text out of a document, which is what I wanted to be able to process it. But one of the things I needed to extract was basically it was a number, it was a template, so it was 1, 2, 3, 4, 5, and it would highlight like the number 5 in blue, and that would mean that I had to take number 5, or if it highlighted, if it was a different form, it would highlight 2 in green or something. So the Textract couldn't extract that, but I needed that image extracted. If I tried to run machine learning over the whole page, it wouldn't work. And I had lots of different types of documents, so I couldn't just do a straight copy and paste from this exact area. So what I actually used was Textract to actually find the coordinates of where that was in each individual location, then crop that location, and then pass it to a small bespoke model that was trained to classify the super simple 5, 4, 3, 2, 1 and select which one. So super simple image classification. So essentially you can get quite creative with these in terms of training models, and you've gone from like a very, very big problem to using the solve problem to solve part of it, and then come up with your own bespoke model to solve a small amount of it, and then it's a lot cheaper with the smaller models. So essentially I'd recommend getting creative with just looking at what the problem is and seeing how much can't be solved already.
Awesome, thank you. And the next question here is, how do you combine 2 data sets with different features but the same demographic to train a single model?
So you got different features. So I'm not sure what you mean by same demographic. I can't think how to pronounce that. So it'd be a case of maybe if there was overlapping features, you could just train on those. Or if if you're mean it's like you've got different features but you've got the same purpose, I think it would be a case where you'd have to find shared data. So you'd either, it might be a case of how you pre-process that data to actually train the model, and you could look at different ways to kind of get to them to the same point. If they have shared attributes or you can get to shared attributes, that would be the thing to look at. Rather than trying to just that's a data processing question, I would say, versus maybe a machine learning question. So look at the data would be my recommendation.
Yep, and we have another question here. Can you please briefly again go through the last example that you conclude to build? Thanks. Just to let you know, everyone, this is all going to be recorded. This webinar will be recorded and put up on YouTube too. But yeah.
Perfect. I'll give a very brief explanation. So it was a recommendation engine. So it wasn't so the reason it was a case of, it was different customers who came in asking for a specific coffee. And Sally built up lots and lots of examples of the customer wanted this, this, and this, and she needed to recommend this coffee. So the example was that she was able to have access to that data, ticking off the second point. There were no big coffee recommenders out there, so there's no existing service, so it wasn't a solved problem. And thirdly, that whenever she did a prototype of the model, that she got pretty good accuracies on it initially. So that solved all three of the questions that pointed towards built versus buy. Hopefully that makes sense. And if you see the slides, maybe step by step, that'll be clear as well.
And then the last one here in the Q&A. Thanks for answering the question. Happy to hear about transfer learning. So I think that would have been from
the recommendation engine. Yeah.
Okay, and then one more in the chat here. Are you taking unstructured data and transforming it into structured data for the coffee recommender system?
Well, that's just the theory of it. So unstructured data would probably be if it was just text, if it was emails and that kind of thing. And it could be that they pull out entities for that and turn into structured data, as you say. So that is the way I'm assuming it would be, but there could be lots of different ways of actually training this model, depending if it's a neural net and if it's deep learning, you might just want to fire a load of stuff in, or if you're going through a standard natural text, you would just go through, you would want to break it down into structured text.
And then we have just another one that came in here. Please share some reference or example for transfer LA.
I have the total same thing of whenever I first started transfer learning, people kept talking about it being a thing, and then nobody ever actually explained how it would work. And I thought it was this huge scary thing. It's really not. If you look at Fast AI, they do a load of it and it's great. I would thoroughly recommend, it's deep learning, but I would thoroughly recommend it as a kind of kickoff if you're a coder wanting to get into data scientist. I wish someone had recommended me it ages ago. It is a really great resource.
Okay, that's all the questions then. Okay, so yeah, I guess I'll close in with a few slides and start wrapping up now. Thanks for answering all those questions, Claire.
Absolutely no problem. Thanks all of you guys for coming along and asking such great questions. It's been great actually doing this presentation. Yes, I said Fast AI. It's if you Google it, it'll come up pretty quick. Sorry for the accent as well. Hopefully that worked okay.
You spoke so clearly. Claire, that's my worry as well, because we're both from here. Like, we talk very fast in Northern Ireland, so it's like trying to slow down when we're talking. But no, you're perfect, Claire. Okay, so yeah, that's us wrapping up now. And this is the next event we have in the data science track. So we're currently running an introduction to NLP workshop series. And I think now we are on week 5. Don't quote me on that because I could be wrong. I think we're week 5. But yes, if you're interested in registering for that there, you can register on the WWCode website /data science. And we have all the recordings up on YouTube. So if you've missed the previous workshops, don't worry, you can catch up there. And if you want to follow us on our social media pages, you can follow us here, and there's a Twitter, our Facebook, and our Instagram. And I also posted a Slack invite into the chat. So if you want to join our Slack community, we post everything in there. So all of our upcoming events are in there, and we have a lot of different channels and different topics. And we have actually a volunteers channel in there as well. So if you're interested in volunteering for a track, we're actually doing an onboarding session next week. So if you're interested, please do join that channel. And follow we also have a data science email address as well. So that'll link to both actually Naomi and I's email address. So it's probably easier to email that address instead of emails individually. And that's us closing up now. So thank you everyone for joining the webinar today, and a big huge thank you, Claire, as well. That was fantastic. And we'll have this recording up soon, and I'll share Claire's slides in the Slack. So the channel you have to join is Track Events, and we'll post that down there in a few days. So yeah, thank you everyone, and thanks Claire. Have a good day.
Thanks everyone.
Bye.
Thanks for coming along. Bye guys.